Question 21. The fourth term of a geometric sequence is 48. The eighth term of the same sequence is 3 over 16. Find the possible values of the common ratio and the corresponding first terms. Start by finding possible values of the common ratio by considering the fourth term and the eighth term of this geometric sequence. Now, in order to find the common ratio, we need to use this formula here. That is, the nth term, or Tn, of a geometric sequence is given by the first term a multiplied by the common ratio r to the power of n minus 1. So in this case, the fourth term is ar to the power of 3, and the eighth term is ar to the power of 7. Now, if we take the eighth term, T8, and we divide it by the fourth term, T4, that's equal to 3 over 16 divided by 48. Now, visualizing this sequence, we know that there are 4 common ratios in between the fourth term and the eighth term. In other words, to go from T4 to T8, we need to multiply by r, that takes us to T5, multiply by r again, takes us to T6, multiply by r again, and so on until we get to T8. So we know that there must be common ratio r to the power of 4 separating T4 and T8. But let's show it using algebra. Now, T8 can be represented by a times r to the power of 7. T4 can be represented by a times r to the power of 3. So ar to the 7 divided by ar to the 3 is equal to 1 over 256. So 3 over 16 divided by 48 will give us this fraction here. Let's consider the left-hand side of this equation. The two a's will cancel, so we're going to be left with r to the power of 7 divided by r to the power of 3 using index laws. That gives us r to the power of 4. Now, there are two ways then to get the common ratio r. Either we can take the fourth root of this fraction, like so, and because the index is even, or another way to think of it is it's the square of the square, we will get two values, a positive and a negative value. Another way to think of it is if we take the square root of r to the power of 4, that gives us r squared, and that's 1 over 16. Notice it's positive 1 over 16 because we have to take another square root to get r. So the square root of r squared is r, and the square root of 1 over 16 this time is plus or minus 1 over 4. So either way, the common ratio, or possible values of the common ratio, is r is equal to plus or minus 1 over 4. Now we need to find the corresponding first terms. So when r is equal to plus or minus 1 over 4, using this formula here again, now that we have a value for r, and we can use either the fourth term or the eighth term, and then solving this equation, given that we have Tn and r, and n of course, we can then solve for a, just by rearranging that equation. So when r is equal to plus or minus 1 over 4, a times plus or minus 1 over 4 in brackets to the power of 3 is equal to 48. Solving this equation for a, we get a is equal to 48 divided by plus or minus 1 over 4 in brackets to the power of 3, and that gives us two values, plus or minus 3072. So possible values for common ratio and corresponding first terms are common ratio equals 1 over 4, first term is equal to 3072, or the common ratio is equal to negative 1 over 4, and its corresponding first term is negative 3072. Alternatively, we can use a diagrammatical approach to solve this problem. And I've used a dash diagram here with 8 places. So there's our first term. If we multiply that by r, we get the second term. So that's ar, ar squared, ar cubed, ar to the power of 4, and so on, until we get to ar to the power of 7. So using this diagram, we can deduce that 48 times r to the power of 4 gives us 3 over 16. and we can get r is equal to plus or minus 1 over 4 this way. Likewise, we can use this to then find the corresponding values for the first term A.